Next, we have 3 problems to calculate the failure rate for the exponential distribution. So this is problems 9, 10, and 11 at the end of the chapter exercises. So we have 3 cases as we talk about on the slides. So case 1 is the time terminates without replacement, and this is in problem 10. So the statement is that 25 parts are tested for 15 hours. At the end of the test, 3 parts had failed at 2, 5, and 6 hours. What is the failure rate? So we first have to identify these different parameters. The R is the number of failures, which is 3. And then the number of items tested is 25. This is the N. The termination time is the time that the test will be terminated if it didn't fail. So then this will be 15 hours, 15. And then we have 3 failure times for the 3 parts that had failed. So that's 2 hours, 5 hours, and 6 hours. Now we have to plug in this formula. So this formula is valid for all the 3 cases. We just have different ways to compute the denominator. So the numerator is the number of tests of failures, which is the R value. And then for the denominator, that's the sum of test times. So for these 3 failed items, the total test times for failures is the sum of these 3 times. So 2 plus 5 plus 6, which is 13 hours. And then the total test times for the passed, for the qualified items, are 15 hours times 22. Right? So we have 25 items tested, 3 of them failed before the termination time. Therefore, there are 22 items that are still survived at the end of the 15 hours. So the total test time for passes is this termination time times the N minus R. Right? So this is 15 times 25 minus 3 times 22, and therefore the total test time for passes is 330. So the sum of test times is this 13 plus 330, and therefore is 343. So the failure rate following this definition is the R divided by the sum of test times. So then that gives us 0.008746 failures per hour. This is a very small failure rate, so it's maybe hard to understand why we have like a small fraction of failures per hour. So to interpret it in another way around, we can use the mean life. So what is the mean life of the item? And that is just 1 over the failure rate. So that gives us 114.3 hours. So that means on average, each part has a life of 114 hours. And therefore, when you test 25 parts, you only have a very small portion, like 3 parts failed at the end of 15 hours. Now for the second case, it corresponds to problem 11. This is the time terminates with replacement. So 50 parts are tested for 500 cycles each, and when a part fails, it is replaced by another one. At the end of the test, 5 parts had failed. And what is the failure rate? So in this case, whenever you have a part that is failed, you replace it with a new one. And then you keep replacing the failed parts until the end of the 500 cycles. And then you count how many parts had failed at the end of the 500 cycles. Therefore, the number of failures is still 5, as what is given in the statement. And then the number of items tested is 50. So 50 parts are tested. And then the termination time is 500 cycles. Now the sum of test times, because every part is tested for 500 cycles, because whenever you have a failure, you replace it. At any time point, in the test you have 500 parts in your system, and therefore the sum of the test times is simply the n times the t. So the number of items tested times the termination time, and that gives us 25,000 cycles, and therefore the failure rate is the R divided by the sum of test times, and which is 0.0002. The mean life is 1 over the failure rate, 1 over lambda, so then that's 5,000 cycles. Now the case 3 is failure terminated. So in case 3, you test every component, you test every part, every item to failure. And therefore you do not have a uniform termination time. You just test everything to the failure and then try to find the failure rate. So the number of failures and the number of items tested are actually the same in case 3. Let's see the problem 9. Determine the failure rate for 5 items that are tested for failure. Test the data in hours are 184, 96, 105, 181, and 203. So the number of failures and the number of items tested are both 5, and then we have 5 failure times: 184, 96, 105, 181, and 203. And therefore the sum of test times is simply the sum of the failure times. And therefore the failure rate is the R divided by the sum of test times, and which is 0.006502, and the mean life is 1 over the failure rate, so that is 153.8 hours.